Hello friends, now we'll discuss about the different type of BLDC motors or BLDC drives. So there are two BLDC drives used in practice: unipolar or half wave BLDC drive or half wave BLDC motor, bipolar or full wave BLDC drive or full wave BLDC motor. So first we will see unipolar or half wave BLDC drive. So what do you mean by half wave BLDC drive? So in this case, this BLDC drive consists of optical sensors. So here we are going to use three optical sensors. So basically those sensors are nothing but the phototransistors. So P1, P2, P3. They are going to be mounted on the non-driving end of the rotor. Okay, and they are going to be placed 120 degree apart from each other, so that every phototransistor or every optical sensor is going to take the responsibility of 120 degree, so that all this together they are going to detect or they are going to sense the exact position of the rotor in a 360 degree. So there is a shutter mechanism on the rotor end. So shutters are going to be opened and closed. Accordingly, the photonic energy or optical energy will be sensed by the sensors and they are going to detect the rotor position, and according to that we have the driver circuitry where we can have three transistors. So every transistor is going to be switched on and off. They are going to be act as switches. So they are going to be on and off according to the signal received from the sensors. So those received signals are going to be processed by the time-based circuitry, and according to that the time-based circuitry is going to generate the signal for these switches or transistors, and the transistors are going to be switched on and off, so that the particular stator poles are going to be generated or stator winding is going to be energized, so that the stator poles are going to be generated and your magnetic rotor is going to be attracted towards that particular stator pole, and hence we can get the torque from the rotor in a particular direction. So as and when shutter revolves, phototransistor are get exposed to the light and they are going to be sensed and they are going to be generate the pulse. So that pulse is going to be processed by time-based circuitry. So here we can have the pictorial representation. So this is the circuit representation of the mechanism. So this is what the stator of the BLDC motor, where we can have three phases. They are going to be connected to the positive supply. One of the end is connected to the positive supply and second end is connected to the transistor, where these transistors are going to be act as switches. So there are three transistors and the transistors are going to be connected to the time-based circuitry, and hence this is the rotor, which is magnetic rotor, and where on the same rotor part we are going to have the shutter mechanism, where we can have three phototransistors are going to be placed. They are going to be acting as a photosensors. So this shutter mechanism is going to be revolved, and it is going to be revolved as and when rotor is going to be rotated. So according to the rotor position, this shutter is going to be rotated and particular transistor is going to be exposed to the light, and hence this particular transistor is going to generate a pulse, and that pulse is going to be processed by this time and base circuitry, and according to that the particular transistor is going to be switched on and off. So let's say the P1 is going to be exposed to the light. So the first sensor is going to produce the pulse and the rest of the sensors are going to produce zero output. So this pulse is going to be processed and transistor Q1 is going to be switched on. So as and when transistor Q1 is going to be on, the negative supply will be provided to the stator, and the second end already positive supply is going to be connected. So phase 1 is going to be energized, and accordingly your rotor is going to be attracted towards that particular phase. Whereas at the same time we can observe that phase 2 and phase 3 are idle. Okay, as and when the rotor attracted towards the phase 1, the next transistor is going to be exposed to the light, and the next phototransistor is going to be exposed to the light, so that time based circuit is going to be generated the signal. So Q2 is going to be switched on and Q1 and Q3 is going to be switched off. So Q2 is switched on, negative supply is provided to the first other end of the phase, and positive is already connected. So this phase is going to be energized, and accordingly rotor is going to be attracted towards that phase, so that the next third photosensor is going to be exposed, and accordingly the rotor is going to be attracted in a particular direction. So every time only one phase is going to be energized and rest of the phases are idle. So this is the mechanism. Because of that reason it is called as a half wave drive mechanism, because only one phase in a picture, whereas rest of the phases are going to be idle. So that is the drawback of or limitation of the half wave drive. So you can see the waveforms. So one transistor is a sensor is going to produce the pulse, rest of the sensors are going to be 0. So this sensor is going to be remain activated or produce the pulse up to 120 degree. For the next 120 degrees, second sensor is going to take the responsibility, so it will again will be in picture up to next 120 degree. At the third 120 degree, the third sensor is going to be in picture, so it is going to take the responsibility of one more 120 degrees. So the one rotation of the rotor is going to be completed, and the rotor position is going to be perfectly sensed by the sensors, and this same picture is going to be repeated. So it has some limitation. So the first limitation is that stator winding are inductive in nature. So as we know that the stator poles where we are going to be wounded the phase, so it is going to be act as an inductor, so that it is going to produce the magnetic pole. So hence stator winding is inductive in nature. It has some energy stored in its winding. As we know, the nature of the inductor, it is going to store the magnetic energy. So as and when we remove the supply from the particular phase, there is some energy still remain in the phases. So that energy is going to create the problem in the drive. So when supply is removed from the phase, it may cause destruction to the transistor, because of the motor cannot be used for power more than 100 watt. So if we go back and if we see, so let's say the phase first was in picture and later on phase 2 are in picture. So phase 1 remain some energy even if we remove the supply. So what it does, it is going to produce the negative current. So that negative current may cause the transistor. So this transistor may get damaged or burned, because the negative current is going to be moved or passed through this transistor Q1. So there may be a chance. So if the negative current increases, then this transistor are going to be destructed. So your complete switching circuit is going to be destructed, and because of that reason these drives are not going to be helpful or not going to be used where the power requirement is very high. So up to the 100 watt it can be utilized, and it is possible to overcome these negative currents by putting one freewheeling diode across the transistor. So if I put one diode in a reverse condition, so the reverse current is going to be moved through the diode, because it is going to provide the conducting path to the reverse current, so we can going to protect our transistors. So that is possible. So hence that limitation can be overcome, and so this is about unipolar half wave drive. Thank you very much.